Okay, we're going to look at complex numbers. Hopefully this won't take too long because this is a review of what y'all did in Algebra 2. We are going to define and simplify imaginary numbers, and then we're going to go through all four of the operations, so add, subtract, multiply, and divide. And yes, please excuse all typos. Okay, yeah, the name is a misnomer. It's very hard for kids to wrap their brain around the imaginary number thing, but it's just kind of like a nickname that got stuck. But they really are numbers. Okay, you do need to know that the definition of I is square root of -1. That is the definition of I. So anytime you're asked what it is, you know automatically it's square root of -1. Now, the cycle of I has to do with the powers. So we're going to go through and we're going to do several powers just to make sure you got it. Okay, so I to the first is just I. Now I squared, that means I times I. Well, we know that's the square root of -1 times the square root of -1. When you multiply two square roots that are the same, you just get what's underneath. So that ends up being -1. Now for I cubed, that means I can do I times I squared. Well, I know that I is just I, there's nothing I can do about it. And then I squared, though, it's -1. So when I multiply those two together, I got a negative I. All right, and then come down here for I to the fourth. Well, there's several ways you could break it down, but one of them is I squared times I squared. Well, I squared is -1, -1. So when I multiply them together, +1. Well, if you keep on, again, there's various ways to break this down. This is just one of them. So I squared happens to be -1. I cubed happens to be -I. So that's going to give me a positive I. All right, one more. All right, so I squared is -1. I to the fourth we found out to be a +1. So if I multiply -1 times +1, it's -1. Now hopefully you caught on to what was happening, because we've got a pattern going on here. We've got I, -1, -I, 1, and then I. This is the same. This is the same. So what's going to happen whenever you do I to the 7th and you figure all this stuff out, you're going to figure out that it's this thing right here. And when you do I to the 8th, it's going to be this thing right here. Because all we're doing is repeating a pattern. So it's going through 4 levels. 1, 2, 3, 4, and then it just loops. 5, 6, 7, 8, 9, 10, 11, 12. So if you know this cycle, you're good to go. So the way that we're going to make it easier to do the cycle is what you need to put in your memory is I to the first, I to the second, I to the third, I to the fourth. You know all those, you're good to go. And it's just I1, I1. And the middle ones are negative. So don't forget that the middle ones are negative. Thank you, John Locke. Okay, now to figure out how it all works, because if I said I had I to the 57th power, I do not want to sit here and count to 57 going through this little cycle. I just don't. I just need to know where I'm going to land. Well, the way you find out how you're going to land is you take all the 4s. So you know every 4th one you're going to loop back, and I just need to know the remainder. So to do that, what I'm going to do is I'm going to take my power, and I'm going to always divide by 4. I want the remainder. Now in old school stuff, we actually really worked with a remainder of 1, 2, 3. Kids nowadays, they're going to pop that sucker in the calculator, and they're going to say, okay, 57 divided by 4, and they're going to get 14.25. Okay, totally disregard the 14. You only are interested in this part, and this is how it works. If you take these exponents right here, and you divide them by 4, 1 divided by 4 is 0.25. 2 divided by 4 is 0.50. And 3 divided by 4 is 0.75. And 4 4 divided by 4 is 1. Now, if you look at that, that means there is no decimal. It's even. So don't get confused on the last one. It goes an even number of times. So over here, where we had 0.25, all that's telling us is that we had one remainder. So 1/4 was what we had. So we're wanting this one. So I to the 57th is the same thing as I. Okay, so if I did I to the 23rd, if I type in 23 divided by 4, what I get is 5.75. I disregard the integer part. I look at the decimal. That matches with the third one. That's 3/4. So that would be negative I. You put what it's equal to. So if I've got I to the 42. 42 divided by 4. I got 10.5. So 0.5, that's the second one. So I'll write down what it's equal to, -1. Now, if you happen to get one like I to the 104, when you divide that out, you're going to get 21, no decimal. Well, no decimal is the last one where it's even. It's a positive 1. So that's how you're going to simplify using the cycle of I. Okay, now these, when you simplify them, you're going to do square roots like you've been doing square roots, but because you've got the negative under there, you're going to get an I. Basically what you're doing is you've got this. You've got -1 times 9. So you've got the square root of -1 times the square root of 9. I didn't break it down like this in class because I assumed you guys kind of figured this out. When you do the square root of -1, you got I. When you do the square root of 9, you got 3. So, I mean, we normally don't write that middle stuff, but that's why it's happening. So the square root of -25, yes, you get the 5, but you got to have the I. You cannot break down the square root of 7, so that stays put, but you do have to take the negative out, and there's the I. Don't let it throw you if it's a fraction. So you do the square root of the top, square root of the bottom, and we need an I. You can write it like that, or you can write it with the I in the top. It doesn't matter. Okay, if you've got problems like these, you do need to simplify the complex number first. So do these, reduce the radicals like we just did. That would be a 10I times 6I. Now when you multiply them, you got 60I squared. Now the rule of thumb is you're not allowed to leave any problem with I with a power greater than 1. So we've got to fix that. Now what we learned a while ago in our cycle of I is I squared was -1. So substitute them out because you did your I1 thing, and that gives me a -60. Now the quick way to do it is just know that I squared will always change the sign of this number every time. So we're probably not going to write this line. We're just going to know that it changes the sign. Okay, but it is structured A plus BI, and you're always going to put the real part first, and the imaginary part is second. Sometimes they call it the complex part, but the whole thing is complex. What makes it complex is the addition of the imaginary part. Okay, if you're going to add complex numbers, all it is combine like terms. That's it. Don't make it harder than it is. So if you combine like terms and you're looking at this, there's nothing in front of the parentheses, either one of them. So you don't really need them. You can drop them. And at that point, you're just putting your constants together. 3 and 2 make 5. You're putting your complex parts together. So 4I and 7I, they're both positive. So you add them up for 11I. If you needed another example, let's just make it just a little bit tougher. Let's see here. Just trying to make something off the top of my head. There we go. So just say we're going to do this one. Oh, and I was bad. I didn't do addition, did I? Okay, so there we go. Let's add. Okay, so if we distribute the 2, which is going to be 4 plus 14I, and then distribute 5, you got 20 plus 30I. You're right back where we were before. Combine like terms. Your real parts go together, and that comes first. Your imaginary part, complex part, comes second. So we got 44I. And that's your answer. Now, when the problem starts with a minus in the middle, that's subtraction. So, I mean, hopefully y'all know that to know what to do, you've got to look in between the parentheses, and that tells you, hey, I'm an addition problem, or hey, I'm a subtraction problem. This one is a little bit tougher because that means that this negative has to be distributed to those two terms. Nothing happens to the front ones, so the front ones just get brought down. You don't need those parentheses, there's not a number. But this negative changes all those signs. So that becomes a negative 2, and that becomes a positive 12i. Then you're right back where you were before. Get your like terms together. That's a negative 7. Get your complex parts together. That's 20i. Excuse me. So let's just do another tough one, so to speak. 3, and then let's just do 4 minus I minus 2 times 7 plus, let's do minus 6i. Okay. So basically you just got to distribute first. So 12 minus 3i, and that's going to be a negative 14, and that's going to be a positive 12i. So these two go together and give you a negative 2. These two go together and give you a positive 9i. And that's your answer. That's as good as you get. And that's basically all there is to adding and subtracting complex numbers. Multiplying and dividing gets a little bit more interesting. Let's scoot on. Multiplying and first is we're gonna encounter this little gem that I squared. He's gonna start popping up a lot, and you've got to remember that thing where I squared is equal to negative 1. So we're going to substitute it out every time because you're not allowed to end with it. But if you'll look in between your parentheses, there's nothing there. They're squished. So that's indicative of multiplication. It's adjunct positioning. So that's supposed to tell you to multiply just like AB tells you to multiply. Okay, so we're going to distribute 3 times everything. So 3 times 2 is going to give me 6. 3 times the 7i is 21i. Now come back with your 4i. 4i times 2 is 8i. And then 4i times 7i, well, that's going to give us a 28, but I times I is I squared. So I warned you it was going to happen. There he is. Now, if I were you, I would just, do this the quick, easy way. We know that I squared is going to change this sign. So just take this, and whatever that sign is, change it. We know it's going to be a negative 28. So now we can put the real parts together, and that will be a negative 22. And we can put our imaginary parts together, our complex parts. And we got the 29i. So same thing over here. Just distribute. 5 times 1 is 5. 5 times 3i, 15i. Then come back with the negative 7i. Don't lose that negative. Negative 7i, and negative 7i times 3i is negative 21i squared. Okay. Let's go in, and with the I squared, remember what you're supposed to do. That's going to change that sign. So when you change it to a negative 1, he's going to be a positive 21. So now I can put my real parts together, and then I can do my complex parts. I got a positive 15 and a minus 7, so it's a positive 8i. And you always want to write them with the real part first and the imaginary part second. That's just standard form. That's basically all there is for multiplying. You could have one like this last one here, but all you have to do is clean it up like we did the other ones. Remember, that's going to be 4i, and then this one's going to be 3i, and you're right back to where you were before. The only other thing I can think of that you might run into would be something like this, and that's just a basic algebra trick to see if you remember your order of operations. It really is not testing your skills with complex numbers. You're supposed to distribute the negative 8 first and bring down the 10. So you got negative 16, that would be a negative 24i. So these two would go together for a negative 6, and there's your answer. So that is just, hey, do you remember the order of operations? Not necessarily complex numbers. We're going to do division in the next video because we don't have time in this one. So see you in a minute.